Alrighty, in this section we're going to go over the Chapter 6 multiple choice component of the AP test. So let's begin. In number 1, a marketing survey compiled data on the total number of televisions in households. If X is equal to the number of televisions in a randomly selected household and we omit weird cases of more than 5 TVs, then X has the following distribution, given in the table right here. What is the probability that a randomly chosen household has at least 2 televisions? So at least 2 televisions means it might have 2, 3, 4, or 5. So to answer this probability problem, we would add 0.2, 0.11, 0.05 to 0.03. We'd add all of those up, and that gives me a total of 0.39. So the correct answer is D. In number 2, we have a different random variable X, and it has this probability distribution, 2K, 3K, 13K, and 2K. This one's kind of weird because we don't happen to know the value of K, this positive constant. We do know it's a constant, which means it doesn't change values, and we also know that these are the only values this probability can take on. So that means that 2K plus 3K plus 13K plus 2K equals 1. So if we add up all those K's, that's 5 plus 13 is 18. Oh, that's 20K. That's equal to 1. That means 1K is equal to 1 divided by 20, which is 0.05. So then, if I wanted to know the probability that X is less than 2, I have to add up the probability that X is 0 plus the probability that X is 1. So that's going to be 2 times 0.05, or 2K, plus 3 times 0.05, or 3K, and that's actually equal to 0.1 plus 0.15, and 0.1 plus 0.15 is my correct answer of 0.25. Alright, in number 3, a business evaluates a proposed venture as follows. So venture means like something like a risk it's planning on taking, or like a business maneuver that it's going to do. Something it might accomplish in the future. So it stands to make a profit of $10,000 with a probability of 3 out of 20. It's going to make $5,000 with a probability of 9 out of 20, and it's going to break even, which means it's not going to make any money, but it's not going to lose any money either. So it's going to earn $0 with a probability of 5 out of 20, and it has a probability of losing $5,000 with a probability of 3 out of 20. So if you were going to make a table of values of X, where X was the profit, how much it would earn, and the probability of X, that table might look like this. $10,000 has a probability of 3 out of 20. $5,000 has a probability of 9 out of 20. Break even, that means it earns $0, 5 out of 20. Loses $5,000, so that means it earns negative $5,000. And again, the probability is 3 out of 20. If we add all these up, hopefully 3 plus 9 is 10, 11, 12. 12 plus 5 is 17. 17 plus 13, excuse me, 17 plus 3 is 20. So we do get probabilities of 1 if we add them all up. But if I want the expected profit, that's like saying the expected value here. We're going to take each of those probabilities and multiply them by their value of X. So 10,000 times 3 out of 20 plus 5,000 times 9 out of 20 plus 0 times 5 out of 20 plus negative 5,000 times 3 out of 20. And if I do my arithmetic correctly here, I'm going to get an expected profit of about $3,000, which is my answer C. So, if that's an expected profit, I would probably take the risk if I was that company. All right, number 4, let's say you roll an 8-sided die. Sorry, that's covered up here by this thing. Let's say we rolled an 8-sided die 10 times. Find the probability of getting exactly 3 sevens in those 10 rolls. So that means we want the probability that x is equal to 3. This is a binomial calculation. We have 10 rolls. We want 3 successes. So we want to multiply, remember it's n choose k, the number of trials, choose the number of successes, times the probability of success to the k power, times the probability of failure to the n minus k power. This is the formula for a binomial probability, right? We should check to make sure that we meet the conditions for the binomial setting, right? So we have independent trials because it's a die that we're rolling. The probability is independent. We have a fixed number of trials. It's 10. The probability is the same every single time. Oh, we should check the bins, right? E-I-N-S. So check the bins. It's either success or failure, so that's the binomial setting or the binary setting. So we meet all those conditions, so we can use this formula. So it's going to be 10 choose 3 times the probability of success. Now, pay attention here. We have an 8-sided die, right? If I want to get a 7 out of that, there's probably a 1 in 8 chance of getting a 7, right? Only one of the sides is going to say 7. And we want exactly 3 of them, so that's raised to the 3rd power. And then the probability of failure, that would be 7/8 times the number of failures I need. The number of failures I need is 10 minus 3, which is 7. So the correct answer for number 4 is B. All right, let's move on to number 5. I guess we get number 4 twice. Let's move on to number 5. If x and y are independent random variables and a and b are constants, they don't change values, which of the following statements are true or is true? If we want the standard deviation of the sum of those two, we can just add the standard deviations. Well, we know that's not true because variances add. The variance of x minus y is equal to the variance of x plus the variance of y. I know that variances add, so that sounds reasonable. The variance of, for number C, I can't see what this says. Oh yeah, it does say the variance of a plus bx is equal to b times the variance of x. But that's not true because variance is the square of the standard deviation, so I can't just multiply the variance by that constant b. I would have had to multiply it by b squared. So C is not the answer. D is not the answer either because when I subtract two random variables, I cannot subtract their standard deviations. And the variance of x plus y is not going to equal the square root of the variance of x squared. This is just like some made-up formula. Doesn't even make any sense. So correct answer is B. Number 6. Let's let a random variable x represent the profit made on a randomly selected day by a certain store. Assume that x is normal with a mean of 360 and a standard deviation of 50. What's the probability that x is greater than 400? Well, I should have given myself more room to answer this question. Let me extend the page and we'll do it maybe down below. So, if x is normal with a mean of 360, we're going to draw a normal curve, and the mean is 360. The standard deviation is 50. What's the probability that x is greater than 400? Well, 400 is only 40 more than 360, so it's a little bit less than one standard deviation above. So the probability that x is greater than 400 is equal to the probability that z is greater than 400 minus 360 divided by 50, or the probability that z is greater than 40 divided by 50. That's the probability that z is greater than 4/5, which is 0.8. So that's 0.8 standard deviations above the mean, and that probability is equal to about 0.2119 for part A. That's your normal CDF. Your low value is going to be 0.8. Your high value, 999. Your mean is 0. Your standard deviation is 1. All right, so that's number 6. I'm going to erase this for number 7. Whoa, there we go. All right, number 7, you select 40 cards from a standard deck of 52 cards. If Y represents the number of red cards, hearts or diamonds, in the 40 cards selected, which of the following best describes this setting? Alright, so this is interesting because we have 40 out of the 52 cards, but we have Y being the event that the card is red. I know about half of the cards in the deck are red. I know it's success or failure, so it's binary. I know that the trials are relatively independent because it's not like I'm picking one out of the 40, looking at it, and then picking the next one. I'm just picking 40. So we would assume that those 40 cards would be independent of 40 cards I would choose in the next trial. The number of trials is fixed, 40, and the success stays the same, hopefully. The part that's kind of weird is this independence, right? So the best answer choice here is Y is a binomial distribution with n equal 40, probability of success 0.5, provided that after we select the card, it's put back in the deck and shuffled again before the next card is selected. So this is the replacement that we were looking for those independent trials. This is why it can't be just A or just B. We wouldn't really have independent trials without that replacement. It's not geometric because I'm not looking for the first success. All right, number 8. In a large population of college students, 20% of the students have experienced feelings of math anxiety. If you take a random sample of 10 students from this population, the mean and standard deviation of those who have experienced math anxiety is what? Okay, so let's recall that the formula for the standard deviation of a binomial random variable is equal to the number of trials times the probability of success times 1 minus the probability of success or the probability of failure. So in this case, that would be 10 times 0.2 times 0.8, or 10 times 0.16, or 1.6 for the standard deviation. And then, of course, the mean is equal to the true mean, the mean is equal to the number of successes times the probability of success. 0.2 times 10 is 2. So my correct answer is, oh, I forgot to take the square root. Hold on. The square root of 1.6 is 1.265. There we go. Stop doing mental math, Roberson. Don't forget your square roots. All right, we're almost done with multiple choice here. Number 9, which of the following is a true statement? The binomial setting requires that there are only 2 possible outcomes for each trial, where the geometric setting permits more than 2 outcomes. Well, that's not true for geometric. Geometric setting is only looking for success or failures as well. It's just looking for when does the first success occur on the first, second, third, fourth, or fifth trial. A geometric random variable takes on integer values from 0 to n. Again, that's not true because it's the probability that the first success is the first, second, third, or fourth trial. C. If x is geometric random variable and the probability of success is 0.85, then the probability distribution of x will be skewed left since 0.85 is closer to 1 than 0. Actually, that would be skewed right. So it's like saying the probability that the first success will be 1 is 0.85. The probability that the first success will be on 2 means you have to have a failure, so 0.15 first times 0.85, your success. So that's going to go down. And then the next one, the probability that the first success is on the third trial, would be 0.15 times 0.15 times 0.85, which is a little bit smaller. So you get the picture. You can see the distribution looks like this. Not skewed left, it's in fact skewed right. And D. An important difference between binomial and geometric random variables is that there are a fixed number of trials in a binomial setting, and the number of trials varies in a geometric setting. That's true because we're just looking for the first success in geometric. I mean, theoretically, the first success could be on the 227th trial, depending on the probability. We just don't know. So there's lots of different values that could take on. And that's not true either. The distribution of every binomial random variable is not skewed right. Words like every, dangerous. Okay, last one, number 10. Jen's commute to work requires that she takes the blue subway line and then transfer to the red line. The length of the trip of the blue line has a mean of 18 minutes with a standard deviation of 2 minutes. The red line trip takes 12 minutes with a standard deviation of 1 minute. The waiting time between when she gets off the blue line and her red line train arrives has a mean of 10 minutes and a standard deviation of 5 minutes. Assume these times are independent. What are the mean and standard deviation of her entire commute? So what we want is the blue line plus the red line plus the wait time. Oh, but since I'm adding random variables, I can add their means. The mean of blue plus the mean of red plus the mean of W. Oh, that's just going to be 18 plus 12 plus 10. That looks like it's about 40. So now we can eliminate D and E. But the standard deviation of the sum of those is going to be the sum. We have to add their variances, right? So the variance of blue plus the variance of red plus the variance of W. And then we want to square root that to get the actual standard deviation. So the standard deviation of blue is 2, so its variance is 2 squared. The standard deviation of red is 1, so its variance is 1 squared. And then the standard deviation of the wait time in between is 5, so the variance is 5 squared. So we're going to add that all up. We're going to get 4 plus 1 plus 25. I'm pretty sure that's the square root of 30. The square root of 30, it's not 8, it's not 2.83, so even without a calculator I can correctly answer that question as B, 5.48 minutes for the standard deviation. And that's it for the multiple choice section. We'll have the free response questions in separate videos.